Alrighty, we're back at it again with the second video. This is we're gonna graph with my beautifully illustrated graph. They don't call us illustration marker or anything. I'm gonna graph a function and find the zeros, y-intercept, and end behavior. Okay, let's start with a pen this time. Okay, so I'm gonna start with end behavior because that's the easiest thing for me to find. For the end behavior, all you kind of just have to do is count how many x's there are. So there's 2x, there's like, the power 2, there's another one here, so 3, and then there's 3 here, so there's gonna be 6, like with power of 6 if you like times them all. Yeah, if you took away everything but the variables, it would just become negative x squared times x cubed, and that would just equal negative x to the 6th power, meaning that there are 6 powers in the total thing, which is trippy. I'm writing it from the camera. Power of 6, which is even. Which even means that it's evens mean that it's like this, and odd would mean it's like that. Yeah, looks like that. Which we're not doing an odd, so that cannot even exist. Doesn't matter. Okay. Since 6 is positive, 6 is positive. In addition to the 6, not the 6. Since the x is negative, it's gonna be droopy because it's like mirrored, essentially over the y-axis. No, sorry, x-axis, not y. Why would it matter? Because anyways, sorry. This is a negative x. Negative x just as existing is a negative. Oh my gosh, I can't believe it. Which means it goes droopy droop. So the end behavior would look like it doesn't look like this because that's not really possible, because it's a it's an interesting looking function. We don't use weird here. It's an interesting looking function, so it probably wouldn't follow like a perfect quadratic because it's not a perfect quadratic. It's special, right? It's not like the others. And so it's gonna look, the endpoints are gonna look like this, hopefully, if I do this correctly, which I am, because I know how to do this. Anyways, enough yapping. I'm going to find the zeros, and it's pretty easy to find the zeros here because it's already factored, and the zeros are, 0, because when you plug so if you put like x, because this is the solution right here. So negative x equals 0. Divide that by -1. X equals 0. It's just 0, and since there's 2 of them, there's 2, so 0 multiplicity, which means there's multiple of them. 2. Nice. And now we're gonna move on to the next one, x minus 1, which when you do that, x minus 1 equals 0. X equals, when you move that over, it becomes x equals 1, positive 1. Which, we're going to add that now. 1. I made this thing way too short. There we go. It's longer now. 1 is also a solution. All right. And then we're going to move on to this one, where it's basically similar to this one, but there's a number now. So x plus 3, x plus 3 equals 0. X equals -3. And since it's the power of 3, I'm brain fart. So the power of 3, there's gonna be 3 of the answers are gonna be -3, type stuff. So you write that as you did this one, similar to this one, but instead of it being 0, it's a number this time. No, 0 is a number. It's a actual. Actually, no, it's not even. It's a negative. -3. Multiplicity of 3. Because it's square root of 3. Ooh, look, it matches. Anyways, now that we have these zeros, I'm going to just find the y-intercept next, which for the y-intercept, just make all the x's zeros, and as you can see, if x is 0, x squared negative 0 divide anything times 0 is 0, so we automatically know that the y-intercept is just 0. It's just cool like that, you know. I did that really badly. Hold up. It looks like oh my gosh, that's a massacre. Sometimes I wish I had pencil. There we go. That looks better. A 0, 0, because 0, 0. All right. Okay, now that we have all our points plotted, what I'm going to do now is I'm going to just put them in my beautifully made, if I might say, beautifully made graph. So y-intercept is 0, 0, so we just make a little dot there. I would use a different colored pen if I had it, but I don't. Okay, so 0, 0. And then for another point, we obviously have 0 as the point here. But they're declared in, so you kind of just have to deal with it. And then the other one is negative 3, so 1, 2, 3 over here. This graph is quite beautiful, if I may add. So 1, 2, 3, 1, 2, 3. And then 1 as our other x-intercept, right? Or zeros, sorry. Okay. We know that the end behavior is going to look like this. So we're going to start it from the bottom left-hand corner, because that's what our endpoint is telling us. That's what this whole thing is telling us, so we can infer from the our brains. It's gonna start from here. We don't really know exactly where it would go, but we're gonna guesstimate with math. All right. Also, so when I'm gonna reach this point, but before I reach that point, I have to remember that negative 3 is a multiplicity of 3, meaning that it's gonna flatten. So whenever it flattens, flat equals odd, then bounce. I'll explain what these are in a second. I spell bounce, B-O-U-N-C-E. I think that's how you spell. I don't know. Well, it's okay. B-O-U-N-C-E. Yeah. Okay, that looks right. Looks right? Yeah, close enough. Yeah, that looks right. Anyways, even that's N. So since negative 3 isn't like it's odd multiplicity, it's gonna be a flatten. So I'm just gonna add flatten right there. And because 0 is a multiplicity of 2, that means it's even, which means it bounces. Boing, bounce. That was yeah. Anyways, as you can see, I'm going towards negative 3. So because it's flattening, it's gonna make a weird shape. It's gonna look like this. Oh, sorry, you can see. Kind of gonna look like this. So we're gonna try to recreate that as effectively as possible. Okay, so it's gonna go up a little bit sooner so you can flatten out, and it's gonna go like this, and then it's gonna go up, right? And then it's gonna go like up, and then it's gonna go to 0. And remember, 0 has a multiplicity of 2, which means it bounces, and it wouldn't bounce this way, because that would mean we would have to go up again, and then we have to go back down, and that would that wouldn't work, because our only zeros are these, or not only zeros. Our only zeros are these. So we can't go like new. We can't do that, because that violates that, and we can't go up here because it would not match the end behavior. Where is it? End behavior. So since it bounces, we know that it's gonna bounce. So it's gonna go wee like that, and it's gonna go down through 1, and it's gonna point that way. And guess what? It matches our end behavior. So it's a weird looking graph, and it's probably not accurate. Even though my beautifully made graph isn't 100% accurate, it still is a sketch of a function, which is what this looks like. And yeah, that's how you graph it. Thank you.